Alright, let's start with the first one. What is the atomic number of xenon? Well, let's take a look at xenon here. Let's make it a little bit bigger. The atomic number is what you're going to find right up here. So the atoms on the periodic table are numbered 1 to 118, and it's the whole number that's up here. So it is, in this case, the answer is, let's do this here, it is 54. So let's move this back to where it was, make it small again. And number 2, what is the average atomic mass of sodium? So we take a look at sodium here. The average atomic mass is this red number here that's written below the name. So in this case, the answer is, we're just going to round it to a whole number. We're going to call it 23. So in our class, we're always going to round the atomic mass to a whole number. Alright, and they do the same thing in AP Chem. Alright, let's see the next one. How many protons are there in an atom of plutonium? Well, let's take a look at plutonium here. How many protons are there? Well, that is what the atomic number tells us. The atoms are numbered 1 to 118 based on how many protons they have. So if we look here, sodium has 11, copper has 29, bismuth has 83, and plutonium has 94. 94. Let's move back here, shrink around down. How many electrons in an atom of copper? Well, here we go. Here's copper. Where does it tell us? Hang on a second. Alright, where does it tell us the number of electrons? Well, that's what the atomic number tells us again, because remember, atoms are neutral. Technically, this number here, the atomic number, is the number of protons an atom has. That's a very difficult thing to change. Copper is element 29 because it has 29 protons, but atoms are neutral, which means they have the same number of protons as electrons, so therefore it also has 29 electrons. So the atomic number is also the number of protons, and it's also the number of electrons in an atom. Let's put this back here. Let's see. Use the atomic mass value for the following elements to predict the most common isotope. We're just going to take the first one. We're going to take bismuth. So let's find bismuth. Here it is. So we're going to look here and say, well, what is the most common isotope? We're just going to take this number here and round it to a whole number. And we're going to predict that the most common isotope is going to be 209. Now, you know what? 9 times out of 10 this works. It doesn't always work. Let's see if it did. So when we look at number 6, well, let me move this back here. Number 6 says, use the back side of your periodic table to look up the actual most common isotope. Now, most periodic tables don't give you this, but this one does. So let's just see. If we flip our periodic table over, you'll see this. Now, notice on the back side we don't have the atomic mass, the atomic number, but we see we have this here. This is isotope notation, and it tells us that bismuth 209 is in fact the most common isotope as we predicted. It won't always be, but in this case it was. Okay, now let's see what we have here. Use the information from number 6 to determine how many neutrons there are in an atom of the most common isotope. So here's how we're going to do that. We want to know how many neutrons there are. So what we do is this. We're going to take this one here, and we're going to say, well, look at this. We have 209 things. Now the way to look at it is this way here. This number 209 that we get by rounding this number here, that is equal to the number of protons plus the number of neutrons. Now what we want to do is if we want to find out how many neutrons there are, we simply take away the number of protons. How do we know the number of protons? It's right here. The atomic number is the number of protons. So bismuth has 83 protons. So let's just take those away. We're going to take away 83 protons, and it looks like that's going to give us 126. So we've got 126 neutrons. Alright, let's move this whole business up. Hang on a second here. Move this up here. We're going to take the whole thing here and move it on up. Which primary particle glues the nucleus together? Well, that would be neutrons. What is the name of an atom that has 14 protons? what I do is I look at the periodic table, I find element number 14, and I see that element number 14 happens to be silicon. And I'm going to be lazy and just write the chemical symbol for it. What is the name of the element that has 79 electrons? Now remember, in an atom, there is the same number of electrons as protons, so I find element number 79, it's gold. So I'm going to write gold. I could be even lazier and put AU, which is fine. You're always welcome in my class to use the chemical symbol instead of the name. Number 11, what name would be given to an atom that has 70 protons and 103 neutrons? Well, you know what? The 103 neutrons has nothing to do with it. The name comes from the number of protons, and the element that has 70 protons is, oh gosh, here you go, ytterbium. Oh gosh, can I even spell it? I would pick something crazy like ytterbium. What is the most common isotope of this element? Well, if I take the atomic number and round it to a whole number, what I'm going to get is 174. Sorry, I don't have a picture like I did for the other ones. What is the name of the atom that usually has no neutrons? Well, there's only one atom. Remember, the purpose of a neutron is to glue protons together. So the only atom that doesn't need them is hydrogen. It only has one proton, doesn't need to glue any together.
Yeah.
What is the atomic number of the atom depicted above? Well, the atomic number is the number of protons. So let's see, we have 1, 2, 3, 4. We have 5 protons here, so it's atom number 5. The number of electrons and the number of neutrons are not what the atomic number is, just the number of protons. What is the atomic mass? The atomic mass is basically is the protons and the neutrons, or if you want to be really cool, the nucleons. It is not the electrons. Remember, electrons are to an atom like fleas are to a dog. They're there, but they don't contribute much in the way of mass. So to find the atomic mass, you just add up all of these. So we already know we have 1, 2, 3, 4, 5 protons. We also have 1, 2, 3, 4, 5, 6 neutrons. So 5 plus 6 gives us an atomic mass of 11. So which element does this diagram depict? Well, what matters is the fact that it has 5 protons. The atom that has 5 protons is called boron. Does this diagram show a neutral atom, a positive ion, or a negative ion? Well, let's just see here. I've got 1, 2, 3, 4 negative particles, those being electrons, and 1, 2, 3, 4, 5 protons. So overall, I have one extra positive thingy. So it is a positive ion. Sorry for the messy writing. If you removed an electron from a lead atom, I wonder what you'd have. Well, it turns out if you did that, what you would have is a positive lead ion, because you'd have one less electron than you had protons. So it wouldn't be an atom, it would be an ion. It'd be a positive ion of lead. So the answer is C. If you removed a proton and an electron from lead, well, it wouldn't be lead anymore, because instead of being element 82, it would be element 81, and that would make it an atom of thallium. Number 19, I guess you move up here, number 19. If you removed a proton from a lead atom but did not remove an electron, well, then what would happen is remember, it can't be lead if it's missing it only has 81 protons. So therefore, it would have to be a negative thallium ion, because it has an extra electron, as many electrons as lead would have, but it's missing one of the protons. And number 20, if you removed a neutron from a lead atom, it would still be lead, but it would have a different mass or different weight, so therefore it would be a different isotope of lead. Remember that the word isotope really is equivalent of saying weight or mass. Okay, hey, good job with your homework. See you next time.